Okay, so we're on to lesson 8 of transformations, and this is combining transformations part 2. Notice that we have an equation here, y equals AF of, and then in brackets, b, and smaller brackets, x minus h, close brackets plus k. In this format, we're looking at a, b, so we're looking at a, which here, and b, and h, and k, and each of these three things basically affects the graph or the equation. Now, as far as the graph goes, a is a multiplier, really, of y, and we can show it either on this side of the equation or over here as 1 over a. When, I can't reiterate this strongly enough, but when the variable is with, when the a, b, h, or k is with the variable, it does the opposite to what you'd expect. Now, having said that, this a value is over here, and the k value is over on this side, which normally would be over here as y minus k. So in this format, the a and the k actually do what you would expect. The a, if it's 2, would stretch, would be a vertical stretch by a factor of 2. And over here, the k, if it's 5, would be a translation up by 5. However, the b and the h are with the variable x, so they actually work opposite to what you'd expect. So b, if b was 5, it would be a horizontal compression by 1/5. And h, if h was 2, this would read x minus 2. It would be a shift to the right, to the positive direction by 2. I'll let you read over the rest of this part here, and it says, note, when graphing a combination of transformations from an equation, use the following order. This is important. So when you're graphing from an equation, this is the order you should do it in. First of all, sketch the original function before it's being moved. So in other words, the original function is just simply y equals f of x before any changes are made. Next, sketch any stretches that happen centered on the x or y axes. Once you've done that, once you get that graph, change that graph by doing reflections to anything that you sketched in step 2. So do reflections to that. Then the last step is, once you've made reflections, change those graphs with any translations that need to be carried out. So what does that mean when we look at an equation like this we're given, and it's asking us, well, original equation is y equals f of x, but now it's gone to this equation here. This is how you would read this equation to go ahead and carry out these 4 steps. First of all, look at the a. Then, actually it's alphabetical order. Look at the a. That's a stretch. Do whatever you have to do to change the graph of this using a. Then look at b. That's a horizontal stretch. Do whatever you have to do to, in that graph that you've just drawn, and do the b stretches. Once you've done that, to that new graph, look at moving it right or left horizontally, depending on what the h value is, and finally move it up or down. Move that graph up or down by k. So here is the first 2 things you look at. Step 1 would include this, followed by this. This is like 1a and b as far as steps down here. Well, actually, I'd say this is a little modification to the way they're doing it down there. Down here, this would be step 1, this would be step 2, this is step 3, and this is step 4. Carry out one after the other. Okay, class example 1. I'll let you look over this, but consider this graph. Consider the function defined by y equals 2 f of a half x plus 5 minus 8. So you can see what's happened here. It's a vertical stretch by 2. It's a so that's an expansion. So this is an expansion by 2 horizontally. We're moving it to the left by 5 and down by 8. So here they've written all the A, B, H, and K values for you. So with those parameters, they've listed here what exactly that means, and that's what I've just said. Vertical stretch, factor of 2, horizontal stretch, factor of 2, horizontal translation, 5 units left, then translation 8 units down. Put these transformations in an order which can be used to sketch the graph of the function, then sketch it. So just use this order in going from A to B to H to K. Read the equation, do this one first, vertical stretch by factor of 2, do this one next, horizontal stretch, factor of 2, move left by 5, move down by 8. So in part E of example 1 above, it mentions graph the equations on your calculator to verify the sketch. So you can go ahead and do that. Example 2, the graph of y equals f of x is shown. So I imagine that's the thin line, I guess, starting here. So this would be 1 point, 2 points, 3 points, 4 points, 5 points, and we can use them in our transformations. So sketch this graph. This looks like a vertical stretch, and then because of the negative, vertical stretch by 2, then because of the negative it's a reflection in the x-axis. This is right by 3, 1 up. Translation 3 units right, 1 up. So you can see what's happening here as far as the replacement terminology is concerned. So looks like you're going to have to do 1, 2, 3, 4 things here, so it's a bit tricky, but you move the points, first of all, the vertical stretch about the x-axis by a factor of 2. So let me pause for a sec. So here what they've done is they've combined these two. The vertical stretch, this point would go down here, and then reflected in the x-axis would take you up here. This point, well, vertical stretch about the x-axis and reflection in the x-axis, this stays where it is, stays put. This one, vertical stretch, goes up to 8, but then reflection takes it down to -8. This one again, on the line, on the x-axis, stays where it is. This one's at 5, it goes to 10, and then should go down. You can't really see it because it's way off the graph here, somewhere down here at -10. Okay, then we've got to translate 3 units to the right. 3 units to the right. So everything goes right by 3 units. So we move our new points. This one would end up over here, I would imagine. And then 1 up, of course. So that would go there. 3, sorry, we're looking at the x's. 3 units right and 1 up would be here. 3 units right and 1 up would be here. Down here, 3 units right and 1 up would be here. 3 units right and 1 up would be here. So now we can sketch this new graph that we have up and down through these points and then straight up here. Okay. Last example 3, consider the function y equals f of x. In each case determine the replacements for x and y, which would result in the following combinations and transformations. The equation of the transform function, determine the equation of the transform function in this form. So we're looking at replacements and the final equation. So we're going to have a horizontal stretch by a factor of 1/4. That's affecting x. X goes to 4x. Okay, so we'd replace that in here. Okay, and then about the y-axis. Okay, fair enough. And then a vertical translation 5 units down. So that becomes y goes to y plus 5. So that would be that, or you can move the 5 over, and that would be the final equation. Vertical stretch by a factor of 3/5 above the x-axis, and a reflection in the y-axis, and then a horizontal translation 2 units left. So let's look about this first. Vertical translation or stretch by a factor of 3/5. That means for y, y becomes 5 over 3y. So that replaces in here. Then reflection in the y-axis. That means all the x's go negative. So we get x going to negative x. So let's replace, well actually they brought this 5 over 3 over here. And then replace the x with negative x. And finally, horizontal translation 2 units down. So, 2 units left. So that would be x goes to x plus 2. So it's the x that gets replaced. Be careful. Not negative x. So negative stays where it is, as you can see, and x becomes this x plus 2. Okay, we can actually take those inner brackets out and just read this as f of negative x minus 2 if you want. So that could read, if you like, 3/5 f of negative x minus 2. Same thing. Okay, I'm just going to quickly go through the last 3 examples because I'm sure you're getting the hang of this. Example 4, function g of x equals x cubed, and it's transformed to a new function called p of x. To form this new function, g of x is stretched vertically. So stretched vertically. Trying to get rid of this blue screen here, sorry. About the y-axis. Pick up my pen. By a factor of 0.25. Okay, stretched vertically, let's just underline what we're doing. By a factor of, so what does that mean? Stretched vertically, the y would become 4y. So that's what we have here. Reflected in the y-axis. Reflected in the y-axis. What does that mean? X's become negative, so we get that here. And translated 3 units. 3 units to the right. That's in the positive direction, so we really should go x goes to x minus 3. So taking this, we replace the y, bring the 4 over, get a quarter x cubed. X goes negative, so that gets negative and still gets cubed. Okay. What else? We can bring that negative out because cubing a negative, it still remains negative, and we've done that here. That's a negative right there. And then finally, this x gets replaced by x minus 3. So that would be our final equation for p of x. Class example 5. Given y equals f of x, sketch the graph of the transform function f of half x plus 3 minus 8. So the original function, I believe, is this line here. I'll pick up my pen. We can see it's this point, this point, this point. I think it's this, and finally all the way down here. So notice we're picking points on the x-axis. When it crosses the x or the y-axes, those are points to pick to transform, as well as endpoints as well, or any corners as the graph is drawn. Well, what's happening here is we can think about what's happening in the order. A seems to be 1, so nothing happens. B is a half, so that means a horizontal stretch by 2. Horizontal stretch factor of 2. And what else is happening? We're shifting it left by 3. Oh, yeah, sorry. This is a little bit trickier now that I remember. Normally we do not want to look at an equation like this, especially this part inside the brackets. That's really what I'm getting at here. This half needs to be factored out from this and this term. So from this and this term. Factoring a half out, we're left with x, but factoring a half out of the 3 actually changes it to 6. In other words, a half times x gives us a half x, a half times 6 gives us 3. Because now we can read what's exactly happening. Yes, it's a horizontal stretch by a factor of 2, but we are shifting to the left by 6. So 6 units left. Okay, because normally the b value, this half, is actually outside the bracket. If you look up at the beginning of the lesson, we really have brackets here and here with the b value outside. So we have to put it in the same form so we can read it properly to know what's happening. Finally, 8 units down. So I'll let you look at that and look at these points and how they move due to these different transformations. Okay, and the very last example here, function f of x equals the square root of x has been transformed into the function g of x, which now equals -2 square root of 3x minus 12 plus 5. Now, notice what's under the function, the square root function. It's 3x minus 12. And really, we need a bracket here. We need to factor out 3 like this, because this is our that'll be our a value right here, -2. This is our b value. This is our h value, and this is our k value. So be careful when you've got something like this to factor the 3 out of both terms. Even if this is even if 3 does not divide it evenly into 12, just like the one above, this needs to be factored too. So if we had something like 3x minus 8, we still would have to write it as 3 with the x in there and minus 8 divided by 3 inside, because that would give us our 3x, and the 3 times this gives us our 8 back. So, alright, so what does that mean for what's happening? It has been transformed by So we have a square root here. The function has been transformed to g of x by stretching horizontally. Yes, I don't know why they're not mentioning vertically first, but stretching horizontally, although it doesn't really matter as long as we've got the stretches first, by a factor of 1/3. Here we are. Vertically by a factor of 2. Reflection in the x-axis. We are translating 5 units up and 4 to the right. And here's the replacement terminology. So please do all the questions in this particular assignment, and we'll see you in class. Oh, by the way, I should mention before we go any further, on Monday there will be a quiz on lessons 1 to 6 in this unit. Quiz will probably take about 15-20 minutes, and then we'll go on with this assignment. Thanks.